Hi students, today I am going to deal the topic magnetic resonance imaging MRI from the chapter modern imaging systems. Today I am going to deal the topic magnetic resonance imaging from the chapter modern imaging systems. Learning objectives. Upon completion of this presentation, you will be able to understand the concepts of the definition of magnetic resonance imaging MRI, the working principle of MRI, advantages of MRI, disadvantages of MRI, and applications of MRI. Upon completion of this presentation, you will be able to understand the concepts of definition of magnetic resonance imaging, working principle of MRI, advantages of MRI, disadvantages of MRI, and applications of MRI. Magnetic resonance imaging. Definition. Magnetic resonance imaging is a technique that uses a magnetic field and radio waves to create detailed images of the organs and tissues within your body. It is a technique that uses a magnetic field and radio waves to create detailed images of the organs and the tissues within your body. Magnetic resonance imaging technique make use of RF region, that is the radio frequency region of the electromagnetic spectrum, to provide an image for body consisting of millions of atoms. Provide an image for body consisting of millions of atoms. Among them, nearly 80% of the atoms are hydrogen atoms. Our body consists of millions of atoms, among which 80% of the atoms are hydrogen atoms. Each hydrogen atom consists of a positively charged nucleus which contains only one proton. You know the atomic structure of a hydrogen atom. It contains only a positively charged nucleus with only one proton, and it is spinning, and hence a nuclear magnetic momentum is associated with it, and the value of the magnetic moment depends on the mass, the charge, and the rate of spin of the nucleus. It depends on the mass, the charge, and the rate of the spin of the nucleus. So a body comprises of several hydrogen atoms, and each hydrogen atom contains only one proton in its nucleus, a positively charged nucleus it has, and it is spinning, and hence a nuclear magnetic momentum is associated with the atom and the value of the magnetic moment depends upon the mass, the charge, and the rate of the spin of the nucleus. What can be diagnosed by using MRI? Why we need to go for MRI? Most ailments of the brain, including tumors, can be ailments of the brain, including tumors, can be diagnosed using MRI scans. Then sport injuries can be identified. Then musculoskeletal problems can be identified. Most spinal conditions and injuries can be identified. Then vascular abnormalities can be identified. Female pelvic problems can be identified. Prostate problems can be diagnosed, and some gastrointestinal tract conditions can be noticed, and certain ENT problems, that is ear, nose, and throat conditions can be studied, and soft tissue and bone pathology conditions can also be studied using MRI. So MRI is very, very useful. It is useful for diagnosing all these problems associated with our body. Who cannot have MRI scan? There are certain limitations where MRI cannot be performed on certain patients, like those who are having a cardiac pacemaker implanted within them. Then certain clips in your head from brain operations, if you have any clips present inside your head, or cochlear implants, or a metallic foreign body in your eye, or if you had a surgery in the last 8 weeks, and if you are a pregnant woman, MRI scan cannot be performed for such type of patients. Patients having cardiac pacemakers, then patients having clips in their head after brain operations, then cochlear implants, then metallic foreign bodies in your eye, or those who had surgery in the last 8 weeks, and if they are a pregnant woman, you cannot have MRI scan. The principle of MRI imaging. The principle of MRI imaging. MRI makes use of the magnetic properties of certain atomic nuclei. It makes use of the magnetic properties of certain atomic nucleus. Certain atomic nuclei. Hydrogen nucleus, single proton are present in water molecules, and water is almost present in all the living tissues in our body. Therefore, in all the body tissues, the hydrogen nuclei partially aligned by a strong magnetic field in the scanner. It is partially aligned by a strong magnetic field in the scanner. So, the hydrogen nuclei, this nuclei can be rotated using radio waves, and they subsequently oscillate in the magnetic field while returning to equilibrium. So, the nuclei can be rotated using radio waves, and they subsequently oscillate in the magnetic field while returning to equilibrium. Simultaneously, these nuclei, they emit a radio signal. These nuclei, after rotating using the radio waves, they oscillate in the magnetic field, and while returning to the equilibrium state, they emit a radio signal. And this signal is detected using antennas, that is the coils, and very detailed image can be made of the soft tissues. You can make a detailed image by measuring the radio signals emitted that are detected by the antennas or the coils. So this is the arrangement of the hydrogen atoms within our body tissues. Their hydrogen atoms are randomly arranged. So when a patient is placed in an MRI scanner, because of the magnetic field, these hydrogen atoms, they align. After the strong magnetic field is applied, they are aligned in one direction. Earlier, they are random in direction. So this alignment causes a radio signal to be generated, which can be sensed by the antenna coils. So this is the applied magnetic field. The spinning nucleus, the hydrogen atom spins. Because of the applied magnetic field, radio signals are generated. Then the main components of an MRI scanner are, you have a scanner, then the computer system and your recording hardware. You have a scanner, the computer system and the recording hardware. An MRI scanner is a large tube. The first and the foremost is your scanner. The scanner is a large tube that contains powerful magnets. They have powerful magnets within it. The main components of the scanner are static magnetic field coils, then we have gradient coils, and then radio frequency coils. RF coils they are called. Radio frequency coils. We have the scanner. Within the main components of an MRI system are the scanner, the computers and the recording hardware. So the scanner is a large tube which contains powerful magnets. It contains powerful magnets. So the main component of the scanner is nothing but a static magnetic field coil. Then we have the gradient coils and the RF coils. We have the gradient coils and the RF coils. So this is the arrangement of our MRI scanner. We have the patient table. The patient is placed on the table and the couch is moved inwards. You have the gradient coils, the magnet, the scanner, the radio frequency coil as I told you earlier, and you have the patient in between the coils. So I'll be explaining detail about this. So as I told you earlier, we have the static magnetic field coils. The static magnetic field coils are used to generate the magnetic field. There are three methods of generation of the magnetic field. They can be fixed magnets or resistive magnets, or you have superconducting magnets. Fixed magnets and resistive magnets are generally restricted to field strengths of between 0.4 Tesla. Okay. So fixed and resistive magnets are generally restricted to the field strengths of 0.4 Tesla. For high resolution imaging system, we use superconducting magnets. The superconducting magnets are large and complex. The superconducting magnets are large and complex. They need the coils to be soaked in liquid helium to reduce their temperature to a value close to absolute zero. Close to absolute zero. So the static magnetic field coils, they produce the magnetic field or generate the magnetic field by three methods. Either we use fixed magnet or resistive magnet or superconducting magnet. Fixed magnet and resistive magnets are generally restricted to field strength below 0.5 Tesla. High resolution imaging systems use superconducting magnets. The superconducting magnets are large and complex, and they need the coils to be soaked in liquid helium to reduce the temperature to a value close to absolute zero. So the next one is your gradient coils. The gradient coils are used to produce deliberately variations in the main magnetic field. The gradient coils are used to produce deliberately variations in the main magnetic field. There are usually three sets of gradient coils, one for each direction. How many sets we have? Three sets of gradient coils, one for each magnet, each direction. We have three directions, X, Y and Z are the common directions we have. So for each direction we have three sets of gradient coils. They are used to deliberate variations in the main magnet, to produce deliberate variations in the main magnetic field. The variation in the magnetic field permits localization of the image slices as well as phase encoding and frequency encoding. So the set of gradient coils for the Z axis are Helmholtz pair, and for the X and Y axis paired saddle coils are used. So along the Z axis we are using the pair called, the name of the coil is called Helmholtz pair, and for X and Y axis paired saddle coils. Helmholtz pairs are nothing but two coils which are parallel to each other along the Z axis. And XY axis are paired saddle coils. They are like a saddle. They form two halves of a hemisphere, two halves of a sphere. Okay, the X and Y together. We can see in the picture. See here, you can see the MRI scanner, how the MRI scanner arrangement consists of. So the gradient magnets we have, see X and Y coils. The yellow color is the Y coil and the red color is the X coil. So they both are perpendicular. They are called saddle coils. They are called saddle coils, and the patient is placed in between them. And we have the Z coil, that is Helmholtz coil. It is called, two parallel coils are there, parallel to each other along the Z direction. So you have a transceiver and the patient is placed in between the scanner. The radio frequency coil. So the RF coil acts as a transmitter and a receiver. The RF coils are the antenna of the MRI system that transmits the RF signal, radio frequency signal, and receives the return signal. They are simply a loop of wire, either circular or rectangular. Helmholtz pair consists of two circular coils parallel to each other. We have two circular coils parallel to each other. They are used as Z gradient coils in MRI scanners. And we have paired saddle coils are used for the X and the Y gradient coils. As I told you, we have 3 gradient coils, X, Y and Z. So the gradient coils are used to produce deliberately variations in the main magnetic field. They are usually 3 sets of gradient coils, one for each direction. The variation in the magnetic field permits localization of the image slices as well as phase encoding and frequency encoding. So the set of gradient coils with the Z-axis are Helmholtz pairs. And for the X and Y axis, it is paired saddle coils. Paired saddle coils. Then, coming to the block diagram of the MRI system. You can see in the block diagram, you have the patient, the magnet and the 2 coils, the transmitter coil and the receiver coil. And the patient is placed between the magnet and the 3 gradient coils X, Y and Z. Each coil is powered, and you have an interface between the coils and the computer. There is an interface, and you can the computer is used to produce your output. It can be further given to a signal processing unit or image storage or display devices. Okay, you have RF generator, RF power amplifier for the transmitter. Transmits the transmitter coil gives the RF signal. Then you have a permanent magnet there. The magnet is the patient is placed in the magnetic field. Okay, this is the block diagram of an MRI system. So you can see the same block diagram can be represented in this form to have a better view. The MRI system can be represented there. See, you have the magnetic coil or the magnetic gradient coils X, Y and Z. The patient is placed. Then you have the radio frequency coil, RF coil beneath, and your gradient power supply to all the 3 coils, that is X, Y and Z coils. And then we have the radio frequency transmitter and a receiver. Through the computer, you can send your using the protocols. You can adjust the frequency of the transmitter, and then you can from the patient you will be receiving the radio frequency signal, and it can be reconstructed using the computers. The image can be reconstructed using the computer, and it can also be viewed according to our requirement. So this is the MRI system. The magnetic coils, gradient coils X and Y, and the radio frequency coil is a Z coil. These are the things which we have seen here. Working principle of an MRI system. The working principle of an MRI system. So, as we have seen earlier, in the earlier figure, we have seen the MRI system. We have the permanent magnet is placed between, the patient is placed in a field of the permanent magnet. So, what is happening here? You are using resistive magnets, as I told you earlier. Resistive magnets or superconducting magnets are used. In a resistive magnet, an electric current is passed through a loop of wire which generates a magnetic field. When we take the case of a superconducting magnet, superconducting magnets are the most widely used in MRI machines at present. They also make use of electricity, but they have a special current carrying conductor within them. These superconducting magnets, they have special current carrying conductor. So this is cooled down to superconducting temperature, that is about 4 degree Kelvin or minus 269 degrees centigrade. At this temperature, the current conducting material loses its resistance for electricity. It loses its resistance for electricity. Okay. So the gradient coils, as I told, the different gradient coils produce a time varying controlled spatial non-uniform magnetic fields in the different directions. As I told you, when the MRI system is in a resting state and not actually producing any image, the magnetic field is quite uniform. or homogeneous over the region of the patient body. Okay. However, during imaging process, the field must be distorted with gradients. A gradient is just a change in the field strength from one point to another in the patient's body. The gradients are produced by a set of gradient coils which are contained in the assembly. Okay. So, the gradients are produced they are nothing but the gradients are, what are the gradients? The gradients are the set of the three gradients. We have gradient coils. The gradient is just a change in the field strength from one point to another. Change in the field strength from one point to another point in the patient's body. Before imaging, when the image is not taking place, the MRI system is in the resting state, and since magnetic field is quite uniform. But when the gradient coils, different gradient coils are used, then when we are imaging, what happens? Different coils will produce different field strengths. Gradient is just a change in the field strength from one point to another in the body. These gradients are produced by the set of the gradient coils, produce a time-varying, controlled, spatial, non-uniform magnetic field in different directions. So what is happening? The patient is placed in between is kept in the gradient field. Okay. Now the patient is placed in the gradient field. So what happens when the patient is placed in the gradient field? A transmitter and a receiver RF coil surrounds the site to construct the image. So the RF coils are located within the magnet assembly and relatively close to the patient body. These coil functions as an antenna. These RF coils, they work as an antenna for both transmitting signals to and for receiving signals from the tissue. So these are different coils designed for different anatomical regions. The three basic types of anatomical regions are the body, the head, and the surface coils. So MRI processors uses RF signals to transmit the image from the patient's body. So the RF energy used is a form of non-ionizing radiation. The RF pulses that are applied to the patient's body are absorbed by the tissues and converted to heat. So a small amount of energy is emitted by the body as signals and are used to produce an image. As I told you, the RF coils work as both transmitter and the receiver. So these coils are located within the magnetic assembly relatively close to the patient. So these coils, they function as antennas for both transmitting and receiving the signals. Transmitting the signals to the body and receiving the signals from the tissues. So we have different designs based upon the different anatomical regions, the body, the head, and the surface coils. So MRI processes uses RF coils which transmit the image from the patient's body. So the RF energy used is a form of non-ionizing radiation. So RF pulses that are applied to the patient's body are absorbed by the tissue and they are converted into heat. A small amount of the energy is emitted by the body as signal used to produce an image. So this image, then a superposition of the linear magnetic field gradient on the uniform magnetic field applied to the patient takes place. Okay, superposition of the linear magnetic field gradient onto the uniform magnetic field applied to the patient takes place. Due to this, resonant frequency of the processing nuclei will depend on the position along the direction of the magnetic field gradient. So, due to which there are resonant frequency of the processing nuclei will depend on position along the direction of the magnetic field gradient. So this produces one-dimensional projection of the structure of the three-dimensional image, three-dimensional object. So you get a one-dimensional image one-dimensional structure of the three-dimensional image. So what is actually happening here is there is a horizontal tube that runs through the magnet and is called the bore. So the MRI magnets are magnetic field of 0.5 to 2 Tesla we are using usually. The magnetic field is produced by passing current through these multiple coils that are inside the magnet. Then we have the gradient coils. As I told you earlier, there are 3 different gradient coils located within the main magnet. Each one of these produce 3 different magnetic fields that are each less strong than the main field. So the gradient coils create a variable field along X, Y and Z, and that can be increased or decreased to allow specific and different parts of the body to be scanned by altering and adjusting the main magnetic field. Then the radio frequency coils transmit radio frequency waves into the patient body. What does the radio frequency coils do? They transmit radio frequency waves into the patient body. There are different coils located inside the MRI scanner to transmit the waves into different body parts. So if a certain area of the body is specified, then the RF coils usually become focused on the body part being imaged to allow for better scan. Now the MRI patient table, this is a component where the it slides the patient into the MRI machine. The position at which the patient lies down on the table is determined by the part of the body that is being scanned. So the area under examination is placed in the exact center of the magnetic field. That is the isocenter it is called. So the antenna, when these radiation RF signals are transmitted into the body, what is happening? The superposition of linear magnetic field gradient on the uniform magnetic field applied to the patient takes place. Due to this, what is happening? Resonant frequency of the processing nuclei will depend upon the position along the direction of the field gradient. So this produces one-dimensional projection of the structure of the three-dimensional object. So the antenna, it detects the RF signal emitted by the patient body and it feeds this information into the computer system. The computer system function is to receive, record and analyze the image of the patient. Its function is to receive, record and analyze the image of the patient. It interprets the data produced into an understandable image. So, by taking a series of these projections at different gradient orientations using XY gradient coils, a 2 or 3 dimensional image can be obtained. The gradient magnetic field is controlled by the computer and the field can be positioned in 3 time invariant planes, X, Y and Z. So the transmitter provides RF signal pulses and MRI signal is picked up by the receiver coil, is fed into the receiver for signal processing. By two-dimensional Fourier transformation, the image is constructed by the computer and is displayed on the television screen. As I told you, the RF signal is picked up by the computer. So what does the computer do? It receives, it records and it analyzes the image of the patient. So it interprets the data produced into an understandable image. Then coming to the advantages of MRI scan. The advantages of MRI scanning are better soft tissue contrast resolution. You have a better soft tissue contrast resolution is available from this. There is a possibility of better soft tissue contrast resolution. Imaging slices can be obtained in multiplanar, sagittal, coronal and oblique directions. Imaging slices can be obtained in multiplanar, sagittal, then coronal and oblique directions. This is all the cases of your brain. The different angles you can observe the image of your brain. There is a total absence of harmful radiations like X-rays. Hence, it is a non-invasive imaging technique. It is a non-invasive imaging technique. It is a non-invasive imaging technique. No ionizing radiation is required. So lack of ionizing radiation is used in pediatrics and obstetric imaging. Okay, so for small children, and many details without IV contrast, variable thickness in any plane, then it does not use iodinated contrast agents, and safe in patients with renal failure. These are all the advantages of MRI scan. MRI scan is you have a better soft tissue contrast resolution is possible here. Imaging slices can be obtained in a multiplanar, sagittal, coronal and oblique directions. There is total absence of harmful radiations like X-rays. Hence, it is a non-invasive technique of imaging, and no ionizing radiation is there. So, variable thicknesses in any plane can be found out, and many details without IV contrast. Then lack of ionizing radiation used in pediatric and obstetric imaging, and it does not use iodinated contrast agents, and it is safe in patients with renal failure. It is safe in patients with renal failure. These are the advantages. Some of the disadvantages of MRI scanning are they are very expensive. This method is an expensive method. It is dangerous for patients with metallic devices placed within the body, like if you have a cardiac pacemaker or any other metallic clips during brain surgeries. It is dangerous to use this for patients with metallic devices placed within the body, and it is difficult to be performed on claustrophobic patients, that is patients who have the fear of confined space, very narrow space. You are pushing the patient into a couch and it is a narrow gantry you have, so it is difficult to be performed on claustrophobic patients. Then movement during scanning may cause blurry images. RF transmitters can cause severe burns if mishandled. Longer scanning time is needed, and it is susceptible to movement artifacts. Cannot be used in acute trauma settings. Does not image the bone and the lungs. It does not image the bone and the lungs. Scanners not available at all places. Scanners are not available at all places and require skilled technicians for operating, and maintenance cost is high. So these are the disadvantages of MRI system. MRI system, it is very expensive method of diagnosing and dangerous for patients who have metallic objects placed within their body, and it is difficult to be performed on claustrophobic patients. It is difficult to be performed on claustrophobic patients, and movement during scanning may cause blurry images. Movement during scanning may cause blurry images. RF transmitters can cause severe burns if mishandled. RF transmitters, they can cause severe burns if mishandled, and longer scanning time, susceptible to movement artifacts, and it cannot be used in acute trauma settings and does not image the bone and the lungs. Scanners not available at all places, and it requires skilled technicians for operating, and maintenance cost is high. These are the disadvantages of MRI. Then the applications of MRI. Soft tissues can be discriminated easily. It is used in study of proton imaging of internal human anatomy, both invasively and non-invasively. Then measurement of blood flow in proton MRI imaging is at present an important research area of potential value. It is used for observing the function of myocardium, that is the heart. It is used to assess the irregularities and heart diseases and infractions and monitor the response to therapy. Water and lipids can be easily discriminated using MRIs. These are the applications. Soft tissues can be discriminated easily, and it can be used to diagnose stroke and tumors of the brain. It gives the functional activities of different parts of the brain, and also measurement of blood flow in proton MRI imaging is at present an important research area. It is used to observe the function of the myocardium, that is the heart. It is used to assess the irregularities and heart diseases, infractions, and monitor the response to therapy. So these are the applications where we are using these MRIs. Okay. Then we have the other areas where MRI can be used. There are several areas of diagnosis. They can be used even in water and lipids can be discriminated easily using MRI, and they can be used for diagnosis of musculoskeletal pathologies of knee and hip and shoulders. Fetal MRI can be used to detect anomalies. Imaging of spine and invertebral discs, and breast MRI for diagnosing breast lesions. Okay, so patients with cardiac pacemakers. So these are all the areas where MRI can be used. Staging of cancer like rectum and cervix and prostate glands. Okay, these are the different application areas where MRI imaging is done. So to summarize our topic of discussion today, we have discussed about what is the definition of magnetic resonance imaging, MRI. MRI, magnetic resonance imaging, is a technique that uses a magnetic field and a radio waves to create detailed images of the organs of the body and the tissues within your body. They make use of magnetic field and radio waves, a combination of both. So magnetic resonance imaging technique make use of the RF region of the electromagnetic spectrum to provide an image for body consisting of millions of atoms. Among them, nearly 80% of the atoms are hydrogen, and each hydrogen atom consists of a positively charged nucleus which contains only one proton. It is the spinning, and hence nuclear magnetic momentum is associated with it, and the value of the magnetic moment depends on the mass, the charge, and the rate of spin of the nucleus. Who can use these MRI scans? MRI scanning can be used for ailments of brain, including tumors, sport injuries, muscular skeletal problems, most spinal conditions, then vascular abnormalities, female pelvic problems, prostate problems, gastrointestinal and tract conditions, ENT conditions, soft tissue and bone pathological conditions. MRI cannot be done for patients who are using cardiac pacemakers, who are having metallic clips in their head for brain operations, a cochlear implant, or a metallic foreign body in your eye, if you had a surgery and we only 8 weeks have passed, and if you are a pregnant woman, for these persons MRI scan cannot be done. The principle of MRI is MRI makes use of the magnetic properties of certain atomic nuclei. Hydrogen nucleus are present in water molecules, and therefore our body consists of body tissues. We have water within our body. So hydrogen molecules partially aligned by the strong magnetic field in the scanner. The nuclei can be rotated using radio waves, and they subsequently oscillate in the magnetic field while returning to equilibrium. Simultaneously, these molecules, these atoms, they emit a radio signal, and which is detected using antennas or coils, and a detailed image can be made of the soft tissues. This is the principle of the MRI system. So the main components of an MRI system are, we have the scanner, the computer, and the recording hardware. An MRI scanner is a large tube that contains powerful magnets. The main component of the scanner is the static magnetic field coils or gradient coils and RF coils. These are the three things: static magnetic field coils, gradient coils, and RF coils. The static magnetic field coils, they're used to generate the main magnetic field. They may be fixed magnets or resistive magnets or superconducting magnets. Depending upon the application, we are going to use high resolution imaging system make use of superconducting magnets. If our field strength is restricted to 0.4 Tesla, we go for fixed magnet or resistive magnet. Then the gradient coils. The gradient coils are used to produce deliberate variations in the main magnetic field. Main magnetic field is produced by the static magnetic field coils. The gradient coils produce the varying magnetic field. The variation in the magnetic field permits localization. We have three sets of gradient coils, one for each direction, that is X, Y, and Z. The set of gradient coils for the Z axis are Helmholtz pairs, and for the X and the Y axis they are paired saddle coils. Okay, so these are the gradient coils. Then we have one more coil called radio frequency coil. The RF coil acts as a transmitter and a receiver. The RF coils are antenna for the MRI system that transmit the RF signal and receives the return signal. They are simply a loop of wire, either circular or rectangular. Helmholtz pair coil consists of two circular coils parallel to each other. They are used as Z gradient coils in the MRI scan, and paired saddle coils are used for X and Y gradient coils. And coming to the working principle of the MRI system, the different gradient coils produce a time varying controlled spatial non-uniform magnetic field in different directions. Now the patient is kept in the gradient field, and a transmitter and the receiver coils surrounding the site to construct the image. Then a superimposition of the linear magnetic field gradient onto the uniform magnetic field applied to the patient takes place. Due to this, what happens? Resonant frequency of the processing nuclei will depend on the position along the direction of the magnetic field gradient. This produces a one-dimensional projection of the structure of the three-dimensional object. By taking a series of these projections at different gradient orientations using X, Y, and Y gradient coils, a 2 or 3-dimensional image can be obtained. The gradient magnetic field is controlled by the computer, and that field can be positioned in three time invariant planes X, Y, and Z. So the transmitter provides RF signal pulse, and the MRI signal is picked up by the receiver, is fed into the receiver for signal processing. By two-dimensional Fourier transforms, the image is reconstructed by the computer and it is displayed on the television screen. So advantages of MRI are better soft tissue contrast resolution, Imaging slices can be obtained in multiplanar, sagittal, coronal and oblique directions. Then there is an total absence of harmful radiations like X-rays, and hence it is a non-invasive imaging technique. No ionization radiation, variable thickness in any plane, many details without IV contrast, and lack of ionization radiation. So it is used in pediatrics and obstetric imaging. It does not use ionized coloring contrast agents, iodinated contrasting agents. Then it is safe in patients with renal failure. So these are the advantages. There are some of the disadvantages with MRI scanning is it is very expensive. It requires skilled technicians for operating and maintenance also. It is costlier. It is dangerous for patients who have metallic objects within their body, and it cannot be used in acute trauma settings. Then susceptible to movement artifacts, longer scanning time. RF transmitters can cause severe burns if they are mishandled. Then movement during scanning may cause blurry images, and it is difficult to be performed for patients who are claustrophobic patients, and it cannot be used in acute trauma settings. Does not image the bone and the lungs. Then the applications of MRI. MRI is used in several areas. Soft tissues can be discriminated easily. It is used in the study of proton imaging of internal human anatomy, both invasive and non-invasive. Measurement of blood flow in proton MRI imaging, and it is used in observing the functioning of the heart, that is the myocardium, and is used to assess the irregularities in heart diseases, infractions, and monitor the response to therapy. And water and lipids can be discriminated easily using MRI. And we have other in the diagnosis of brain and spinal cord diseases, staging of cancer like rectum, cervix and prostates, in the diagnosis of musculoskeletal pathologies of knees, hip and shoulders, in fetal MRI to detect anomalies, breast MRI for diagnosing breast lesions, and cardiac MRI for assessment of myocardium. So these are the various areas where MRI imaging is done. So with this, I would like to end my presentation about magnetic resonance imaging, MRI scanning today.